Okay, so not all equations are short and small, and so now we're getting to where our equations are getting larger, and so you're having to perform different tasks in order to get that variable by itself. So with this section, we are going to have variables and constants on both sides of the equal sign. So it's a little bit more involved than what we've been doing in the past. Let's start off with a little bit of a review. 4x plus 6 equals negative 14. So we have to look at this and see what's happening to our variable. Well, it's being multiplied by 4. It's also being added by 6. So here's what you want to do in order to solve these equations where you have more than one operation going on. You want to undo addition and subtraction before you undo multiplication and division. So to start this one off, we're going to try to move everything away from that x. So I want to subtract 6 from both sides of that equal sign. So 6 minus 6, that creates 0, so that went away. So what's left on the left side is plain old 4x is equal to a negative 14 minus 6 is negative 20. Now what's happening to the variable? It's being multiplied by 4, so you want to undo that with division. So x is equal to negative 5. And again, this is something that we can test. So let's check our answer. 4 times negative 5 plus 6, does that equal negative 14? So 4 times negative 5 is negative 20. Negative 20 plus 6 is negative 14. So that is true. I know that this is my answer. Now you may want to consider doing this very same problem over and over and over again until the process becomes second nature to you. So my recommendation, grab a sheet of paper, write down this problem maybe 5 times and work it over and over and over again. And the steps that I'm going to be grading are this one, and your final answer. So practice over and over again. I promise you this gets easier the more you do it. Okay, so let's take a look at this one. 2y minus 7 equals 15. What is happening to our variable? It's being multiplied by 2 right there. It's also being subtracted by 7. Undo addition and subtraction first. So I want to add 7 to both sides of that equal sign. That is a negative 7 plus 7, so it goes away. You're left with just regular old 2y on the left. 15 plus 7 is 22. Now, what do you have to do to solve this? 2 times y equals 22. How do you undo multiplication? You undo multiplication with division. Divide both sides by 2. So y is equal to 11. And now you can check your work. So let's check this. So I want 2 times 11 minus 7, and I want to know, does that equal 15? 2 times 11 is 22. 22 minus 7 is 15. So I know that this is my correct answer. Again, this might be a problem that you want to do several times to check yourself and make sure that you understand the process and how to show your work, because I will be checking your work. The steps that I'm going to be looking at, did you show that step? Did you show divide by 2? Did you give an answer in the form of a variable equals a number? Those are the things I'm going to be looking for. Okay, so I want you to take a look at this problem right here. 5x is equal to 4x plus 7. I want you to notice that you have a variable on both sides of that equal sign. You have to move one of them. If I were to move 5x, don't do this, I'm just showing you what would happen. If I moved 5x from the left side to the right side, Here's what I get. 5x minus 5x is 0. 4x minus 5x is negative 1x or negative x. And this really didn't help me a whole lot. I need to get that x by itself. So that is probably, although it's not a wrong move, you just have added a step in order to get your answer. So my recommendation for this problem right here, I'm going to erase this, is to maybe subtract 4x from both sides instead. So 4x minus 4x, that's 0. So 5x minus 4x, I get just plain old x, equals 7. And the problem is now finished. So can we check our work? Sure can. So let's put 7 in where we have both of our x's. So I've got 5 times 7. Is that equal to 4 times 7 plus 7? 5 times 7 is 35. 4 times 7 is 28. 28 plus 7 is 35. So I know that this is the correct answer. All right, so let's take a look at this one. 5y minus 8 equals 7y. If I were to move that 7y from the right side to the left side, I've just pulled every single thing over to the left side. And you don't want everything on the left side. You want your constant equal to your variable or your variable equal to your constant. So my recommendation for this problem, subtract 5y from both sides. 5y minus 5y creates 0. So the left side I'm going to bring this straight down. I've got negative 8 is equal to 7y minus 5y is 2y. Now I want to divide both sides by 2. Always divide by the number in front of the variable. Negative 8 divided by 2 is negative 4. 2 divided by 2 creates 1. So there's my answer. Negative 4 equals y. I could also write that as that. Either way, it does not matter. So now to check my work, I'm going to put negative 4 in where I see y. 5 times negative 4 minus 8, does that equal 7 times negative 4? 5 times negative 4 is negative 20. Negative 20 minus 8 is negative 28. So I know that that is my correct answer here. So I'm pretty certain that y equals negative 4 is the correct answer. So 7x equals negative x plus 24. So I want to get my x's on the same side of the equal sign. I want my constant term on the other side of the equal sign. So for this problem, I would add x. And remember, that's a 1x there. If you want to put the 1 in front, that's fine. It doesn't hurt anything. What is 7x plus 1x? It's 8x. Negative x plus x creates 0. Positive 24, I'm going to bring it straight down. Now, to solve this, I need to divide both sides by 8. X is equal to 3. Now I can check my work. So I've got 7 times 3. Does that equal negative 3 plus 24? 7 times 3 is 21. Negative 3 plus 24 is 21. So I am certain that is my correct answer. So of course the problems are going to get more involved. What'd you guys expect? Okay, so here's what you want to do here. I have a variable term and a variable term. One is on the left side of the equal sign, one is on the right side of the equal sign. I also have a constant term on the left and a constant term on the right. So what you want a variable term equals a constant term. That's what you're looking for here. So here's my recommendation. I usually will grab my smallest x term and move it first. It is not a requirement that you do this, it's just my recommendation. There are other ways to work this problem, and as long as you do the math right, it's not wrong. But this is how I'm going to work it. So I'm going to grab my 6x and I'm going to move it from the right side of the equal sign to the left side of the equal sign. 7x minus 6x is 1x or just x. I'm going to bring that straight down. This created 0, and I brought that straight down. Now this looks like something we've dealt with before. We can solve this equation pretty easy. So now let's subtract 5. So x is equal to 2 minus 5 is negative 3. So now let's check our work. So I'm going to put negative 3 everywhere I see x. So 7 times negative 3, again, I always go back to my original problem. Does that equal 7 times negative 3 is negative 21. 6 times 3 is negative 18. Negative 21 plus 5 is negative 16. Negative 18 plus 2 is negative 16. That works, so I know this is my correct answer. Alright, so take some time to read through this. You might want to hit pause right now because I'm not going to leave this running indefinitely. So go ahead and hit pause, take some time, read through this, and it's everything that we've already been doing, so just read through it. Alright, so let's look at this one. 6n minus 2 equals negative 3n plus 7. So I told you that my plan is I always grab my smaller variable term. So I'm going to grab that negative 3n and I'm going to move it over to the 6n. When you move something from one side of the equal sign to the other, you have to do the opposite. So you want to add 3n there. What you do to the right side, you have to do it to the left side. 6n plus 3n is 9n. I'm going to bring that straight down. This created 0, and I'm going to bring this straight down. So now I want to get this n by itself. So I'm going to add 2. So I've got 9n is equal to 9. And I want to divide both sides by 9. So n is equal to 1. So now you can test your answer. So I've got 6 times 1 minus 2, is that equal to negative 3 times 1 plus 7. 6 times 1 is 6. Negative 3 times 1 is negative 3. 6 minus 2 is 4. Negative 3 plus 7 is 4. So I know this is right. Okay, 2a minus 7 equals 5a plus 8. Again, I grab my smaller one, so I don't always pull my variable to the left side. If you're a left side variable person, then you can always do that. I tend to pull my smaller one to my larger one. So my smaller variable term is 2a, so I'm going to subtract 2a from both sides of the equal sign. That creates 0. Bring this straight down, I get negative 7 is equal to 5a minus 2a is 3a. Bring that straight down. Now I want to move everything away from the 8, so I'm going to undo addition first. So I'm going to undo addition with subtraction. Negative 7 minus 8 is negative 15. Signs are the same. Add the numbers together, keep that sign. So now I'm going to divide both sides by 3. Okay, so now I'm going to check my work. 2 times negative 5 minus 7, is that equal to 5 times negative 5 plus 8? 2 times negative 5 is negative 10. Positive 5 times negative 5 is negative 25. Negative 10 minus 7 is negative 17. Negative 25 plus 8 is also negative 17. So I know this is correct. Look at that. Now we have fractions in the equations. You know, as if the rest of it wasn't enough. But come on. I had to make this a little more difficult, right? Okay, so again, I'm going to pull my smaller variable term to my larger variable term. So I'm going to subtract 1/2 x from both sides. That created 0, so that's why I marked through it. 3 halves minus 1 half is 2 halves. And what is 2 halves? It's just 1. So it's just plain old x. Bringing that down, I've got plus 5. So now what I want to do is I want to subtract 5 from both sides. X is equal to negative 8. So let's put negative 8 in where we see x. So 3 over 2 times negative 8 plus 5, is that equal to 1/2 times negative 8 minus 3. 3 halves times negative 8, 2 will go into negative 8 4 times. 3 times negative 4 is negative 12. Is that equal to half of negative 8 is negative 4. Negative 12 plus 5 is negative 7. Negative 4 minus 3 is also negative 7. So I feel certain that's correct. You guys knew I couldn't stop at fractions, right? Now I've got to throw some decimals at you. So I'm going to subtract 1.6 from both sides. 1.6x, sorry. So 3.4 minus 1.6. I've got to borrow. 14 minus 6 is 8. There's 1.8. X plus 4 is equal to negative 5. Now the next thing that I would do is I would subtract 4 from both sides. So I've got 1.8x is equal to negative 9. Divide both sides by 1.8. And x is equal to negative 5. Might be a good time to grab that calculator if you're not sure about that. I did. Okay, so now I'm going to check my answer. So I'm going to do 3.4 times negative 5 plus 4. Is that equal to 1.6 times negative 5 minus 5? So on my calculator I'm typing in 3.4 times negative 5 and I get negative 17. On my calculator I'm typing in 1.6 times negative 5 and I get 8. Sorry, negative 8. Negative 17 plus 4 is negative 13. Negative 8 minus 5 is negative 13, so I know that this is the correct answer. Okay, again, go ahead and hit pause here and read through this page. Okay, so now we've got some distributive property here. So I want to multiply. First I want to distribute, okay? So I want to multiply 3 times x and 3 times 2. So 3 times x is 3x. 3 times 2 is 6. And now, next thing I do, I subtract 6. So I've got 3x is equal to 12. Divide by 3. X is equal to 4. Check your work. 3 parentheses 4 plus 2. Is that equal to 18? According to order of operations, I need to add those together first. So 3 times 6. 3 times 6 is 18. That is correct. Okay, this problem right here, this one messes with a lot of people. They don't realize that just because that negative sign is in front of that parenthesis, that really what you're doing is you're distributing a negative 1. So you need to do negative 1 times x, which is negative x. Negative 1 times 5 is minus 5. Now I want to add 5 to both sides. So I've got negative x is equal to 12. And that's not my answer. I want plain old x. So in order to get rid of that negative sign in front of that x, I could either multiply by negative 1, or my habit is to just divide by negative 1 every time. But multiplying by negative 1 would also do the same thing. So now I want to check my work. Negative 12 plus 5 is negative 7. Negative times a negative is a positive. So that is correct. Okay, so we've got 4 times the quantity x minus 2. Then we add 5 equals negative 3. So the first thing that you want to do here is you want to get rid of those parentheses by distributing. 4 times x is 4x. 4 times negative 2 is minus 8, negative 8, plus 5 equals negative 3. Now, anytime you have more than one constant on the same side of the equal sign, you need to combine them before you start moving them around. And so what we get here, negative 8 plus 5, this 4x I'm bringing straight down. Negative 8 plus 5 is negative 3, so I put minus 3. Now this looks like something we've dealt with before. So I want to add 3 to both sides. I get 4x is equal to 0. So I divide by 4. 0 divided by 4 is 0. So in this case I get an answer of x equals 0. So now we can test that out. So 4 times 0 minus 2 plus 5, does that equal negative 3? 0 minus 2 is minus 2. 4 times negative 2 is negative 8. Negative 8 plus 5 is negative 3. So x equals 0 is my answer. Alright, I want to caution you with this problem right here. Most people, if they miss this problem, it's because they did not follow the order of operations. Order of operations says I need to get rid of my parentheses before I start doing addition and subtraction. Please, please, please do not do 8 minus 2 first. That is wrong. So, and you'll get the wrong answer. So the first thing that you want to do is you want to get rid of those parentheses. Okay? So this 8 I'm bringing straight down. Negative 2 times 3y is negative 6y. Negative 2 times a positive 5 is a negative 10. Now what I want you to see, we have terms that we can combine on the same side of the equal sign. So what is 8 minus 10? It's negative 2. I'm bringing this straight down. Now you want to move everything away from that variable, so I'm going to add 2 to both sides. And now I'm going to divide by negative 6. So y is equal to negative 2, 6, which is the same thing as negative 1/3. And you can check your work even with a fraction. So let's do that. So I've got 8 minus 2 times negative 1/3. Oh, I forgot something, sorry. Times 2, 3 times negative 1/3. Plus 5, does that equal 0? So the first thing I want to do is this right here. 3 times negative 1/3 is negative 1. Now I need to combine that. Negative 1 plus 5 is 4. Now I want to multiply here, so 8 minus 8, and that is 0. So y does equal negative 1/3. This was a tough one, I know. You may want to do this one several times, but please, please, please do not start by combining these. That is wrong. I mean, you knew this was coming, right? So let's take a look at this. We have things that we have to distribute on both sides of the equal sign this time. So I've got to multiply 3 times x and 3 times negative 2. I'm also going to multiply 4 times 2x and 4 times 1. 3 times x is 3x. 3 times a negative 2 is negative 6. I'm going to bring this straight down. 4 times 2x is 8x. 4 times 1 is 4, bringing this straight down. Now I'm going to combine my like terms on both sides of the equal sign. So I've got 3x, negative 6 minus 5 is negative 11. 8x, I don't have anything to combine that with. 4 plus 5 is 9. Again, I will grab my smaller variable term and move it to my larger. It's just out of habit. That goes away. I'm left with negative 11 on the left. 8x minus 3x is 5x. My next move will be I subtract 9 from both sides. Negative 11 minus 9 is negative 20. And now I want to divide by 5. So this is negative 4 is equal to x. So let's test it. So I'm going to put negative 4 wherever I see x. So I've got 3 times negative 4 minus 2 minus 5. Is that equal to 4 times 2 times negative 4 plus 1 plus 5? So I want to do this and this first. So I've got 3 times negative 4 minus 2 is negative 6. 4 times 2 times negative 4 is negative 8. Negative 8 plus 1 is negative 7. 3 times negative 6 is negative 18. 4 times negative 7 is negative 28. Negative 18 minus 5 is negative 23. Negative 28 plus 5 is negative 23. That is correct. I just want to say, this is a very involved problem. It is long. You have to do it step by step. You have to be neat on your paper. And if you aren't neat, if you aren't paying attention, it is very, very easy to mess up. And I want you to know that I messed up a lot whenever I was first starting to do this. All the time I messed up. So if you don't get this on your first try, it's okay. Keep working, keep practicing. I promise you it does get easier. I promise. You just have to keep trying. Alright, so I've got to distribute my 1/2 times each term inside the parenthesis. 1/2 times 6x is 3x. 1/2 times a negative 2 is a negative 1. Notice how I have a constant term on the left and right. I've got a variable term on the left and right. I'm going to grab my smaller variable term and move it to the larger one. 3x plus x is 4x. Bringing that straight down. So I'm going to add 1 to both sides. So I get 4x is equal to 6. Divide both sides by 4. X is equal to 6/4, which is the same thing as 3/2. You always need to reduce your fractions. So now I'm going to check my work. So I've got 1/2 times 6 times 3/2 minus 2. Is that equal to 5 minus 3/2? So 6 times 3/2, let's see here. I've got 9 minus 2, which is 7. 5/2 minus 3, or sorry, 5 minus 3/2. 5 can also be written as 10 over 2, right? 10 divided by 2 is 5 minus 3/2. So now 1/2 times 7 is 7/2. 10/2 minus 3/2 is 7/2. So I know this is correct. Okay, so let's just throw some decimals at you. Again, these aren't that bad. As long as you've got your calculator in front of you, it's okay to use it. Just make sure you're still showing your steps. You can go ahead and do the math on the calculator. So 0.24 times 100x is 24x. 0.24 times 5. I'm doing that on the calculator. 0.24 times 5, and I get 1.2. So plus 1.2. Now I'm going to distribute this over here. 0.4 times 30 is 12. So I get 12x. 0.4 times 15 is 6. Again, used a calculator. So now I'm going to grab my smallest variable term and move it to my larger variable term. 24x minus 12x is 12x. Now I want to subtract 1.2 from both sides. So I've got 12x is equal to 6 minus 1.2. Divide both sides by 12. And I get that x is equal to 0.4. So now let's test it. So 0.24 times 100 times 0.4 plus 5. Is that equal to 0.4 times 30 times 0.4? Sorry, I'm squishing. Okay, so on my calculator, 100 times 0.4. So 100 times 0.4 is 40. Then I'm going to add 5 to that. So I get 45. So I've got 0.24 times 45. That's what I get on the left. On the right, I'm going to do this part first, then I'm going to add 15. So 30 times 0.4, I get 12 plus 15, and I get 27. So I've got 0.4 times 27. So now on my calculator, I'm going to do 0.24 times 45, and I get 10.8. Now on my calculator, I'm going to do 0.4 times 27, and I get 10.8. And I know that those are equal to each other, so I'm certain this is the correct answer. Okay, again, these last several problems, very involved. It's very easy to mess them up. If you are all over your paper and you are not writing things down neatly, there's no way you're going to get these right. So make sure that you create a habit of doing things nice and neat, show one step per line, give yourself plenty of room, make it look good, make it to where I can follow what's going on your paper. That's how you get partial credit. And just be careful and do these problems over and over and over again. I know, who has that kind of time? But try to make some time every single day to work some problems, and they will come a lot easier to you eventually down the road.